Hello, welcome to Redox equations. By going through this recorded video, you will be able to identify atoms and ions that get oxidized and reduced, balanced redox reactions, suitable for A-level chemistry year 13 learners, A2 level. Some parts are also suitable for year 12 learners. Okay, the initial part where we actually look at what gets oxidized and reduced is suitable for year 12 learners as well. I would like you to practice these along with me with a pen and paper as we go through the balancing equations, the skills required for this. It will be really useful to be ready to practice some of them. So pause the video from time to time and practice these skills along with me. That will be more useful rather than just watch me all the way through, because I'm going to go through many examples today. To start with, you should be really familiar with the oxidation number rules, which is the number that we assign to each of these atoms when they are in a compound or in an ion. Okay, so let's have a look at each of these and make sure that you can remember this and apply these. Groups 1, 2 and 3 metals, they have oxidation states of 1, 2 and 3 respectively. Say if you look at the periodic table, group 1, like say lithium, so lithium, sodium, cesium, they all have +1 oxidation state. And group 2, like magnesium, have 2+. Aluminium in group 3, 3+. Okay, aluminium has 3+, and so on. Okay, so that's what that means. For fluorine, when it forms compounds such as lithium fluoride, we're just looking at really simple compounds. Lithium is a +1 and this becomes a -1, and it's always -1. There are no exceptions. Hydrogen forms +1. Always we give +1 number oxidation state for hydrogen, except when it's a metal hydride. What that means is if it forms a compound with a metal, then it's a metal hydride, in which case, so in this case we have is a -1. Lithium is a plus. Lithium's got a plus charge and +1 oxidation state, and H is given -1 oxidation state. Okay, so all the other times we give +1, right? For example, H2SO4, so that will be given as +1 for each hydrogen, because we have 2 hydrogens like that. And for oxygen, we'll see this is going to be -2, and there's 4 of this, so totally we have 8 charge over here. So this allows us to find the oxidation state of something that we're not familiar with, sulfur, and also sometimes it can vary. Okay, but these are kind of set, so we start off with these things as our priority, and then later on we'll see how we work out the oxidation state of sulfur. Let me just finish that example here. Now what these numbers are for, this is an example of why we use these oxidation number. So in a compound like this, or even in an ion like this, 2- sulfate ion, we can work out the oxidation state of sulfur based on what we know. So we are familiar with oxidation state, and for that one we can figure out sulfur's oxidation state. So let's finish with this sulfuric acid example. There is no charge on H2SO4, so we have +2 +2 here, and then the total of -8 here, so +2. And compounds, to be neutral, all the charges should cancel out, and there's no charge on this compound. So if you add up all this, it should be neutral. So to work out sulfur's oxidation number, what we have to do is add this +2, then -8. You can put plus sulfur should be 0. Okay, so total of this is -6. So you can see for this to be 0, sulfur has to be +6. Okay, so that's the use of this oxidation number. I'm sure you're familiar with this. If not, make sure you really learn the oxidation number rules that you first possibly learned in year 12. right? So if you look at sulfate ion here, same rules we know about oxygen is coming next page here. So oxygen's got -2, so let's apply that over here now. Except in peroxides, we'll see what that means in a minute, right? So let's look at oxygen, how it is applied in an ion like so, SO4 2-. So we don't know about sulfur, but we know about oxygen is going to be -2 in this case. So we have total of -8 charge, because each oxygen will have an oxidation state of -2, and total of -8. So we don't know about sulfur, but total we have is -2, right? So for this to become -2, sulfur has to be +6. So +6 add -8, you'll end up with -2, which is the charge over here. So again, sulfur has got a +6 oxidation state here. So we are able to work out oxidation states of atoms in a compound by knowing the oxidation rules, right? So that's what this is for. H2O2 in peroxides, it is -1. So this oxidation number in mostly in all the other cases it's -2, but when you see a peroxide like this, so if you look at H2, each one has got +1, so you have +2 charge totally. And for oxygen it has to be -2, right? But there is 2 oxygen atoms here, so each oxygen will be assigned a charge of -1. So O is going to be -1 in this case. So each oxygen atom, because you got 2 oxygen atoms here, each oxygen atom has been assigned a -1. That's what this means. In peroxides you have -1 oxidation state for oxygen. I hope that is all right. You probably are familiar with this. But then in compounds with fluorine being even more electronegative than oxygen atoms, you have a +2. So oxygen can have +2 oxidation state only in this case. So that's an exception for this, okay? So beware of this. In peroxides and fluorine compounds, you have a different oxidation state assigned for oxygen atoms, right? For chlorine, it's always -1 mostly, but then it can also be +1 and various other charges as well. So this has to be worked out. So just mostly, so if you see chlorine, be careful, don't give that as a priority, work that at the end, okay? We'll do practice of this, don't worry. So for now, chlorine is generally -1, but then it can change in chlorates, okay? So one example of a chlorate is, for example, KClO3 potassium chlorate, and chlorine's oxidation state is not -1. Okay, we'll see that later on. So for now, you know it's not always -1. Okay, but for halogens, generally you can give a -1. If there is with practice, you'll know why this is. Most of the time it's going to be -1, except when you have oxygen, chlorates, any oxygen atoms, so you prioritize oxygen first and then go with the halogens. The same for iodates as well. Okay, so generally you give -1 for halogens. Okay, remember all elements have 0 oxidation state. For example, O2, Cl2, if you see any of this, oxidation state for the atoms that's present here is 0. So same with any metals as well. So if you see Ca, calcium, you know, so any metal that you see, or any element you see for that matter, oxidation state is 0. Okay, you may be wondering, H2O2 is a covalent compound, right? Now these oxidation states are give a charge given to atoms assuming that the compound is ionic. Now this may sound a bit strange, but this helps us to identify what gets oxidized, what gets reduced. That is the whole purpose of this, right? Now it's got like real good applications, so make sure that you know these rules and be able to apply. But bear that in mind, these numbers are assigned to atoms even in covalent compounds, not just ionic compounds. Okay, so for example H2O2 is not ionic. More rules. Okay, total oxidation state in a molecule is 0. Say for example CO2, that's a covalent compound, right? So this is a neutral molecule. Applying the oxidation state rules, oxygen's got -2, except in peroxides or fluorine compounds, any compound that's making fluorine. Other than that, it's -2. So we have -2 because of 2 atoms here. We have a total charge of -4 here. So the carbon will have an oxidation state of +4. Now you may be thinking, that's not ionic. How can carbon have a charge? That's all okay, but this is like only for the numbers are assigned to see what's getting oxidized and reduced. That's what the purpose of this is, right? So the total oxidation states in a molecule is 0. Elements, we know it's 0. Oxidation is 0. The total oxidation state in an ion is a charge. What does that mean? It's the total of oxidation state. SO4 2-, NO3-, PO4 3-. So this is the total charge on the whole ion. So the total oxidation state of the ion is the charge on the ion. So the oxidation state of the total oxidation state of all these atoms is the charge on the ion. Let me give an example. Let's take that one. Okay, so you have 3 oxygen atoms, and we know each oxygen's got a -2 charge. So times that by 3, so we have a total charge of -6 for these 3 oxygen atoms, and there is a total charge of -1. So -6 add something else as x equals -1. So for nitrogen, whatever the charge is, you put that here. So you can put x and solve for this, but you can pretty much see what this number is going to be, is +5. Okay, so nitrogen in this case has got a +5 oxidation state, and that is what this means. Okay, the total oxidation states in an ion is the charge on the ion, so we have to take that into account. So to work out the oxidation state of sulfur, you need to take that the total of these atoms together should give you -2. Let's do one more example of this, right? Then you have for 4 oxygen atoms it's -8, and then add something. It should give you -2, which is the charge on the atom, right? Then what's missing here? So for sulfur, whatever the oxidation state is, you add that to -8, you should get -2. I suggest you don't put x and solve for this. You need to really fast with this. So you can see this is +6, right? +6 -8 gives you -2. So this sulfur will have a +6 oxidation state, and oxygen, as we know, is -2. Okay, so I hope that helps. You can actually have a go at this, working out the oxidation state of the atoms that are underlined. Mind you, these are all just neutral compounds, they're not ions. Okay, so the oxidation state of oxygen here and phosphorus and so on, anything that you have underlined, and I don't have that here, let's underline that one, nitrogen. Okay, so then here it's chlorine and the chromium here. Okay, so all these underlined atoms, you need to work out the oxidation state. I'm going to show you 1 or 2 examples, but if you don't need examples, pause now, have a go. I'm going to go through some examples, right? There. Okay, so KClO3, right? So we're going to put potassium +1 because that's in group 1. 3 times -2 is -6, and we know this is going to be 0. So +1 -6 is going to be 0. Plus I'm going to add something else, right, for chlorine. Now this reduces to -5, so this has to be a +5, right? Should be equal to 0. So chlorine in this case is +5, right? Now anytime you feel confident, okay, I'm going to have a go at these, please pause, and I'm going to go through the answers assuming you've done that. Okay, so N in this case +1, -4 for two oxygen atoms. Then for nitrogen, because this is going to be 0, +1, and that I'm getting -3, so this has to be +3. And as you can see, +1, +3, +4, -4, 0. Okay, so you should add up to 0. 1 + 5, 6, -6 is 0. Okay, so anytime, like I said, pause and check. Oh, this is a peroxide. What do you think? So this is +2 for two sodium atoms, and for each oxygen atom, the total of this is going to be -2, right? So for each oxygen atom, the oxidation state is -1. Okay, because you have two oxygen atoms, the total should be -2, because for each sodium atom it's going to be +2. So as you can see, the oxygen atom in this case, because it's a peroxide, it's -1. Okay, this is the answer. For sodium oxychloride, what do we get? So +1, and chlorine is, we need to find the chlorine's oxidation state. We don't know, right? So oxygen, in this case, it's not a peroxide, it's not combined with fluorine atoms, so we can actually put -2 here. So this is something like a priority. We know the priority atom for this, right? Now we don't know about chlorine. Chlorine can change, vary, right? So this is +1 and -2. So +1, -2, and I need to get a 0 here. So what should I do? So the chlorine is going to be +1. Okay, so chlorine has got an oxidation state of +1. Aluminum nitrate, so we need the oxidation state of nitrogen here. Aluminum, you know, it's in group 3, so I'm going to put +3 here. And this is going to be, like, you have to be careful with this because you need to expand this out, right? So 3 times 3. You don't have to actually do this. If you know the NO3's oxidation number is -1 already, right? Like I said, you can expand it out, or if you know how ionic substances work, aluminum's got +3, so the total of this is going to be -3, right? So for each nitrate ion, it's going to be -1 because you have 3 nitrate ions, right? So let's just reduce the problem down to this, right? Now we know it's easy to solve rather than just working out, expanding out and looking at all the atoms and so on. Just look at the nitrate ion, just like this, -6. The total should be -1, which is the charge over here. Okay, so whatever nitrogen's oxidation state, you add that to this, it's going to give me -1. So as you can see, this, you're going to need +5 for this. So the oxidation state of nitrogen in this case is +5. Okay, iodine, right? For chlorine, the rule is, so our priority is to go with the chlorine because chlorine is something that we know, except in compounds with fluorine or chlorates, it is different. So in this case, we're going to give it a -3. So iodine in this case is +3. Also, if you know, the convention is put the positive first and the negative second, right? Another thing to consider is chlorine is more electronegative than iodine, right? So that's more likely to be the negative part of this molecule. Okay, said, if you want to pause now, feel free to do that. I'm going to go with one more example. See if you can actually work this out yourself. For nitrogen, not for nitrogen, for chlorine here. Okay, so we know this is ammonium chlorate. Okay, so this ammonium ion will be positive. This is really useful to know some ions in ionic compounds, right? So this is ammonium ion. So if that is +1, this whole thing is going to be -1. So our problem is now reduced to just work out this. Okay, so as you can see, for 4 oxygen atoms, it's going to be -8. So this overall charge, you're going to get -1. So the number for chlorine would be obviously +7, right? So +7, +7 -8, that gives you -1. So the oxidation state of chlorine in this compound here is +7. Okay, you really have to pause this video now and check your answer once you worked out the oxidation state of all of these atoms I've underlined. Okay, some of them I've done, that you can do the rest of them. These are the ones that are done. You can now check your answers, right? I hope you have paused the video and practiced these, trying to work out the oxidation states of these atoms, right? So let's have a look at this one. Some of these are worth going over. Let me just go with this one here. Okay, ammonium chloride. I just did that, but just like reminder, this ammonium has got a +1 charge, so this whole chloride has got -1 charge, so the total should be -1, so -8. So that's why chlorine has got +7. So for 4 oxygen atoms you got -8 here. So chlorine has to have an oxidation state which when you add them two together you should get -1. Okay, so chlorine can only be +7 in this case. Same with this as well. It's useful to split like this: potassium dichromate, 2 potassium. So that means the whole of this bit is going to be -2, or you can just put all the numbers here. So I put for this one first and then for oxygen, because we know that's for sure. We're trying to work out the chromium's oxidation state here. So 14 for 7 oxygen atoms. 7 times -2, 14. So 2 plus -14 gives you -12, right? So the 2 chromium atoms here should have a total of +12 oxidation state to make that into a 0. Okay, so for 2 chromium atoms it's +12, so for each chromium atom is going to be +6. That's how we get the oxidation state for chromium atom in this one. In the same way, let me just go through this as well, right? So first 2 sodium atoms is +2, -6. So we have an excess of -4 here. +2, this is the neutral atom, so we're going to need a +4 for 2 sulfur atoms. So for each sulfur here you have a +2 oxidation state. Okay, so the sulfur here has got +2 oxidation state. Okay, now let's have a look at oxidation state of some ions. Okay, now let's turn our attention to finding the oxidation state of atoms that are underlined in ions. So the total charge of all the oxidation state in each of them should be equal to the charge on the whole ion, right? I'm going to give you an example, just to remind you of how to do this. Cr2O72-. This originally is from Na2, Cr2O7 sodium dichromate. So let's just look at this ion, Cr2O72-. So the total should be that. Okay, so for oxygen we know that it is -2, so we're going to start with oxygen. That's going to be -14. Now to get a -2, what should be the charge of the 2 chromium atoms here? So that should be +12. So when you add +12 -14 gives you -2. That's for 2 chromium atoms, mind you. So for 1 chromium, that's going to be +6. So the oxidation state of chromium is +6. Now I hope you can try the rest of them. You can pause the video, and I'm going to go through the answer in a moment. Okay, so time to check your answer. I hope you got them all correct. Pause the video to check your answers carefully. Here is more practice for you, so you can, if you're not comfortable doing that, if you feel like you need more practice with this, You can try these compounds and ions in some cases, okay, and then check the answer. Pause now. Here's the answer to what you have just done, so you can check if you got them all correct. That's the question. Answer here, check.